Hi class, looks like my previous video got cut off. Sorry about that. I'm still learning all of this, so I'm trying to make this work, okay? So thank you guys for bearing with me. All right, so we're gonna do B. As you notice, I distributed or I multiplied this 2 to every single exponent. Remember the 6 is still raised to a first exponent, so exponent of 1, I should say. So you're still gonna multiply. You're gonna go, I'm going to write it down like this so you guys can see exactly where it comes from. All right. 6 times 2 is 2. So you have 6 to the second power. Okay. Then you have x to the 8 times 2. And you're going to get x to the 16th power. All right. And then you have y to the negative 3 times 2. All right. And so negative 3 times 2 is negative 6. Okay, so far so good. Well, if you remember our fourth rule up here, we can't have negative exponents. So because this is technically over 1, we turn this into a fraction, and this drops down, this y to the negative 6 drops down below. Okay, so this problem becomes 6 squared x to the 16th y to the 6. It's positive. Now, go ahead and multiply or do the exponent rule 6 to the second power. All right, I'm going to write that over here because I'm running out of room. I have 36. 6 squared is 36. X to the 16th, y to the 6th. And there's your answer for that one. These are tough. I think, like I said, the negative rule is the most complicated one. Okay, and I apologize if this video is a little shaky. I have to hold it a little differently than my previous device. Okay, all right, let's do the other one here. Okay, and then we have one more thing that we need to talk about. Okay, same thing, but now we have a negative exponent. So we can put this 1 on this 3, if you see that. So I'm just going to do the problem. All right, 1 times negative 2, that would make it 3 to the negative 2. Negative 5 times negative 2 would be positive 10. Remember, signs matter. And then 8 times negative 2 is negative 16. Okay? So we have negative exponents. Let's fix those. The ones with the negative exponent will go into a denominator when we turn this into a fraction. Okay, so I have x to the 10 over 3 squared y to the 12th. And you should go ahead and multiply out or find the value of 3 squared, which is 9. All right, awesome. Great job. Woohoo, good job, you guys. All right, one more thing, one more concept to look at, and then I'll call it a day on these videos and give you the assignment. All right. The next thing with notes has to do with converting from radicals to rational exponents. Rationals or anything can be written as a fraction. Okay. If you notice here, we have our radical. Now our understood typical radical is your square root. Okay. For instance, we talked about square roots. Okay. Oops. There's no number here. This is an automatic 2. So this is the one time where it's understood to be a 2, not a 1. So the square root of 4 is 2. Square root of 9 is 3. Square root of 25 is 5. Okay. I think it would be a good idea if you get to know your basic square roots, like perfect squares and the opposites, okay? So what happens here is that we take the exponent that's on the right-hand side, that moves up to the numerator, and the exponent that's on the outside of the radical, that moves to the denominator, okay? All right, so let's look at a few of these problems just to change them, okay? And I know you guys, some of you have questions on it. So remember, I do have my office hours, Monday through Thursday, 1 to 2, and then Fridays by appointment only. Okay. And by appointment only, I would be available up until about 2 o'clock. Okay? But I want you to take advantage of this time. I highly, highly urge you and strongly suggest that you get in touch with me on my office hours should you have questions. Okay? All right, let's look at A in problem 2 section. Okay, we're going to have our radical where we have the fourth root of x raised to the 7th power. So the 7 is going to become your numerator and the 4 is denominator. Don't make it harder than it is. I promise if you follow the formula that's listed at the top, you'll be able to go backwards and forwards. I promise. I promise. Okay? It does take practice, and sometimes you have to feel like you're standing on your head, turning around 3 times to understand it, but I promise that's where it comes from. Okay? Let's look at B. Okay, skip down to this one. Okay, we have t, the square root of t to the 3rd power. Normally we wouldn't have that 2 there for a square root, but for practicing we have it here. So your numerator is going to be the inside exponent, the outside is going to be the denominator. So that's t to the 3/2. Okay. Let's look at C. Okay. Same thing here. Don't be daunted by this. Okay. 5 times x to the 5/3. Okay. And then look at D. There's an understood exponent, or excuse me, root. It's a square root, not exponent 2. Understood root of 2. Okay, and I'm going to loop that right back up to what we did at the notes. Okay? All right, so that becomes 2x to the 9/2, or 2x to the 9/2. I kind of ran out of room there. Okay? And now we do the reverse. Okay? We can do the reverse. Remember, the numerator is the one that goes with the radical on the inside with that number, and the one that's in the denominator is your root. It goes on the outside. Okay, so let's look at that here. Look at A. Okay, always draw your radical first and put your base inside your radical. Okay, that's like half credit right there. Okay, you always want half credit whenever possible. Half credit is better than no credit, right? So this 3 is going to go right here. This 5 is going to go on the outside. You tuck it between where these 2 lines form a V, because that's where your root belongs. Okay? All right, let's look at B. Your 2m is going to go inside your radical. Your 7 is going to go right here. And your, excuse me, my bad, I apologize, I screwed up. Your 2 is the exponent that goes here. And the 7 is the one that goes inside the little radical space. Okay? Outside of the radical sign. Okay? I'm sure that some of y'all would have caught me on that had I done that in class. Okay? Any questions? If there are, make sure you ask me. Okay? It's probably better to send me an email and let me know that you want to have office hours. Okay. Because I will definitely be available between 1 and 2 Monday through Thursday. If not, I will let you know for sure. Okay, let's look at C. 5y goes under the radical. This 5 in the numerator goes here on the right. This 3 is the little root that's tucked in right there. Okay, same with D. You know I gotta have my colored pens, y'all. I grabbed those from school. In there. And you technically don't even need that 2 right there, but I'm not gonna ding you if you put it there. Just know that you might not see it, so I'm gonna write it another way. Okay, so just be careful. When you get the higher level math, you will be penalized for putting the 2 there. Okay. All right. Let's look at the bottom here. Use the rules of exponents to write each following expression as a single radical. Okay, well, here we have 2y's and 2 exponents. This goes back to our product rule. Okay, product rule, where we take the like bases and we add the exponents. What's really nice about these exponents here, even though they're fractions, they have the same denominator. If you remember your fraction rules, you must have the same denominator. So I'm going to take this step by step. Notice how I have y to the 3/5 plus 2/5 because you add the exponents. Okay. Well, what is 3/5 plus 2/5? Well, you get 5/5. Well, when we reduce that fraction, what is 5/5? It's 1. So y to the first power is simply y. Careful, you still got to know your fraction rules. You're never going to get away from them. Sorry, y'all. That's just the way it works. Okay. Look at B. Change that radical on that root where you have the radical. Change that to 5. Let's not do too many crazy things right now. Okay. What I would like to do, I'm going to go ahead and change this, or rewrite this problem how I want it. Okay. And I'm going to turn this radical form into rational exponent form. Okay, so I'm going to keep my first one as the same. And if there's no exponent here, that's an automatic 1. This exponent is the numerator. This 5 is the denominator. Okay. The bases are the same. So we add those exponents again. Okay. Remember, with adding or subtracting fractions, you have to have the same denominator. Well, 5 and 5. And we add our numerators. Okay. And it wants us to write it as a radical. We didn't put it as a radical form with a because there was no reason for us to do so. You can't have one root of something. So that's why you leave it as it is. But this one, if we change to single radical, this 5 is the root. The denominator goes on the outside. And the exponent on the top, the numerator, goes with the y. All right, one more. Okay. Let's change these. Okay, I think it's better if we change them. It may be going around our elbows to get to our feet. Oh, I'm so sorry. If we go ahead and change those into rational exponent form, then add your exponents. Okay. 8/5 plus 2/5. Well, that turns out to be 10/5, doesn't it? Okay. Well, what's 10 divided by 5 is 2/1, or just 2. So there's no reason, there's no denominator other than a 1 now, so there's no reason to put it back in radical form. Yes, these do take practice. If we were in class, we would have a ton of classwork on this because it is difficult. All right, so your homework is on the homework sheet, obviously. Okay. You are going to do problems 1 through 6. So 1, 2, 3, 4, 5, 6. Those are simply using your exponent rules. And then the bottom problems, okay, I want you to do number 7. You need to find least common denominator. That's a challenge one. Don't run away from a challenge. Okay. And then do number 8 and number 11. I think that's enough practice. That's big picture stuff. Okay? All right. Let me know if y'all need help.